Vicker hardness test. So this Vicker hardness test is similar to Brinell hardness test. It is used to measure the hardness on metals as per ASTM E384 standard. So this Vicker test is also known as micro hardness test. It is used to find the hardness of small or thin material sections. The surface of the material must be made smooth and highly polished. While measuring the hardness using the Vicker's test, the surface of the material which is to be tested should be made smooth and it should be highly polished. So the testing process involves using a square based diamond indent. You are applying the force or indentation using a square based diamond indenter and apply a light force on the surface of the material. So the loading value ranges between 10 grams to 1 kg. That is this Vicker hardness, micro hardness. We can use to measure the hardness on some lesser thicker material. Thickness of the material is very small. We can go for the Vicker hardness. The indentation is caused by the application of load which is measured optically. So there is a camera system available in the measurement system. So you can measure the indentation automatically using the camera. See, this is the Vicker indenter. The indenter angle is 136 degree. It is a square based diamond shaped indenter. So here after the indentation, you are measuring the dimension of the indentation, that is D1 and D2. After that you are getting the indentation. You are measuring this D1 and D2 using the camera. See here, you are having the indentation using the Vickers hardness test. So in the sample 1, it is having a smaller indentation compared to sample B and sample C. So sample C, the indentation is more. So by comparing this alone, I can tell the sample A is harder material, sample B is of medium hard, and sample C is a softer material. So comparing the table of different materials with different Vicker hardness, we can tell the diamond material is having a higher HV compared to stainless steel. So the material value, that is HV value, is more. We can tell it is the hardness of the material is more. See here, it is a diamond indenter of angle of 136 degrees. It is used to apply the indentation over the workpiece. The workpiece will be definitely formed in the shape of the indenter, and you are measuring the D1 and D2 values. You are using the formulas. You can calculate the Vicker hardness number. See here, this is the Vicker's hardness test setup. It is used to measure the Vicker's hardness number, where it is equipped with a digital type of machine, equipped with system also, and also it has an integrated camera. So what happens? This first initially the indenter, using the indenter, you can apply the load, then you rotate the camera so that you can measure the indentation diameter automatically. There is an integrated system. It calculates the diameter, it calculates the diagonal lengths, and it automatically calculates the Vickers hardness number in HV. See here, this person is measuring the Vicker hardness number of a specimen. The camera is fitted so that he can directly monitor the diameter, the indentation diagonal size, so that the particular machine will calculate the Vicker hardness number automatically. Same thing, the digital Vicker hardness measurement system. So coming to the merits and demerits of Vicker hardness test. So one of the advantages in the Vickers method is it can be used for checking any type of specimen or any type of material. Since it is a micro hardness type of test, it will create a small indentation on the specimen, right? So this specimen, this method, it can be used to measure the hardness on any type of material or specimen. So demerits are some specimen preparation are required here. So to polish the specimen, you can grind it, you can clean the specimen because it involves a lot of optical measurement and other cameras because any grease surface or oil surface on the workpiece or the test surface will spoil the system. So it is necessary to grind or polish the specimen, and also it is necessary to maintain a clean surface of the work surface material. And there is no need to conduct separate optical indent evaluation. Why? Because in Brinell hardness test, what we do, we will measure the indentation depth using the optical measurement device or optical microscope. But here, the system itself equipped with the optical microscope. What you are doing after indentation, you are rotating to the camera so that the camera will perform the imaging capture, and it measures the diameter or the diagonal size of the diagonal, and it is a slow process. It takes nearly 30 to 60 seconds for measuring the Vicker hardness test of a particular sample. It is a non-destructive type of test which leaves the indentation in the test surface. The indentation is very small, and also it is not going to damage the material. Only a small indentation will be present on the surface of the material. Coming to the most important disadvantages, it is an expensive system because it involves the optical system, integrated system with camera. So it is an expensive system. Coming to the comparison of Rockwell and Fresnel and Vickers hardness, in Rockwell test, no specimen preparation is required, but in Fresnel test, specimen preparation is needed. In Vickers test, specimen need to be prepared. In Rockwell test, hardness value is directly readable, so no optical evaluation is required. In Fresnel hardness, good illumination of the test indent is important for ensuring the correct evaluation of the test indent. But in Vickers test, due to the need how to conduct the optical indent evaluation, Vicker hardness tester must be equipped with an optical system. In Rockwell test, it is a quick and cost-effective process. But in Fresnel test, the process is slow. But in Vickers hardness, the process is very slow. Compared to the type of testing, Rockwell hardness test is a non-destructive type of testing. All the hardness tests also non-destructive testing, but in Fresnel hardness, it will leave a large impact, that is large indentation on the surface of the specimen. This Rockwell test not always measure the most accurate hardness testing method, but in Fresnel hardness, high risk of deforming material to be tested when testing in the macro range with high test loads. More expensive to purchase than Rockwell test due to optical system. In Rockwell, the test location must be completely free from contamination. That's why we are going for the specimen preparation in the Rockwell test. Similarly, the Fresnel hardness test also we want to prepare the specimen. Vickers hardness test also we want to prepare the specimen. The indentation has unknown effects on the test results in Rockwell hardness. Coming to the Fresnel hardness, relatively large test indents that are easier to measure that are smaller Vicker indentation. In Vickers, only one type of indenter is used. Under Rockwell, with increasing hardness, it becomes difficult to distinguish the hardness between the materials. Under Fresnel hardness, it can be used for testing non-homogeneous type of material, that is casting type of material can be tested under Fresnel hardness material. Under Vicker hardness, this method can be used for all materials and all test samples.